Okay? So that I get, integrating both sides, I get volume is equal to integral of 1/2 g of z f of z dz. I need to figure out what these g of z, f of z are. Well, we know they're linear functions, right? Because it's clearly aligned. So, and we know that g of z, so let's call that g1 z plus g2, and let's call f of z f1z plus f2. And g1, g2, f1, f2 are just some constants that we need to determine. So, we know that g of 0 is equal to 0. Right? Because at z equals 0, the distance out is, or the distance this way, is 0. And we know that g of 5 is equal to 3. Similarly, we know that f of 0 equals 0, and f of 5 equals 4. Okay? So now I plug these conditions in. G of 0 is just equal to g2. So I know that g2 equals 0. If g2 equals 0, then I have g of 5 is just 5g1. And 5g1 is equal to 3. So that g1 is equal to 3/5. Okay? Similarly, for f2, I get 0. Because if I plug in 0 here and 0 here, I get f2 equals 0. And similarly, once again, we get 5 times f1 is equal to 4. So f1 is equal to 4/5. Okay? Is that clear? So just plugging into the formula we had before for the volume. Yes?
How do you know that g of 0 is 0 and g of 5 is 3?
Because by g I mean this length across here at some sliver. So if z is equal to 0, then I'm at this tip here. So it doesn't go out at all. It's a point. G is, if I look at this triangle here, right? It's this triangle at z equals 5. It's this triangle at z equals z naught. And it's a point at z equals 0. So G is how far out one of the sides goes. Yeah?
So G1 and F1 are ratios or are they actual values?
They're rational numbers.
Rational.
They're constants. They're the slope.
Yeah, exactly.
Okay? So now, doing my integral, I have v is equal to integral from, let's say, 0 to 5, 1/2. Well, let's write what g of z is equal. If g1 is equal to 3/5 and g2 is equal to 0, then g of z is equal to 3/5 z. Similarly, f of z is equal to 4/5 z. Okay? So integral of 1/2 times g of z times f of z gives me 3/5 z times 4/5 z dz. This is integral from 0 to 5. 1/2 times 3/5 times 4/5 is 12 over 50. Or I could simplify that. So that's over 25 times z cubed over 3, taken from 0 to 5. And that's just 6 over 25. 0 doesn't matter because it cancels. And now we have 125 over 3. 25 and 125. This goes to 25. No wait. 5. So we get 5/3 and then 6 and 3. This goes to 2, so I get 10. Is that a little clearer than last time? I know it's still kind of difficult to grasp.
Is that 31? Yeah. Can we just use the tetrahedron volume formula? Because I got the same answer.
Yeah.
But it's a calculus class.
Oh, this is so hard. It's 1 over 3 base times height.
Well, 1/3 the area of the base times the height.
Yeah.
And the area of the base is the 3 times 4
3
times
times 4
1.
divided by 2.
Yep. So that's actually a kind of interesting question. It's true that if we take any surface parallel to the xy plane, and we draw what's called the cone of that surface, which is, say that this is the distance h above, and we draw the cone, which is just a set of straight lines from the boundary of the surface to the origin. If this has area A, then the volume will be 1/3 area times height. And this might be interesting to try to prove using this method. But maybe not in this class right now. Do you have more questions on the homework? Alright, we can start the quiz. So please write quiz 4, your name and your section at the top. Section 6, right? If you're in this section, then you're in section 6. If you're in the morning section, then that's section 2. Minus x squared, minus 2. find the volume of the solid given by rotation of the region bounded by y equals 4 minus x squared and y equals 0 about the x-axis. I can write this in the fact shop if you'd like to see. Oh, and I have your old quizzes for you, if you wanna stay. I'll give them to you after this quiz. Also, I posted your grades on Blackboard, so please check them and make sure there's no mistakes.